Okay, so let's see the steps in executing an interrupt using an example. The code is given for us, and the AVR itself. We have got the program counter initialized at 000 and the stack. Now, few things over here. Now, at 0, we have got the location for reset. Okay, so this is from the interrupt vector table. The reset is at address 0, and we just directly jump to main, which is over here. And in between that, we have got the ISR. From the ISR vector table, we are going to use interrupt 0. So interrupt 0 is at location 2. Okay, so external interrupt 0 request is at location 2. That's why we write .org hex 02, because the ISR routine will be at that location. And we just say jump external 0 ISR. So whenever the interrupt comes in, it will just pop in over there. Okay, let's start executing the instruction fetch, decode, and execute cycle. And let's see how program counter, stack, and the flow of the program is changing. So we start, and when we are in 0, it will jump to the main, which is at program at counter is pointing to address 4. So we'll jump to address 4, where we are initializing the stack. So the program is fetching and executing LDI high remand, and the program counter points to the next location, which is 5. Then we execute SPH, and then the program counter shows 6. Then low remand, program counter shows 7, and then we define the stack where we have got the end of the RAM memory, which we are going to use the stack pointer over there. Then we carry on. DDRC bit 3 or pin 3 is going to be an output. We set it. Port D bit 0 will be pull up activated. So port D bit 0, which is interrupt 0, external interrupt 0, is going to be a pull up activated. So the resistor and the pull up over there, it's going to be pull up activated. So when there's a push button which is pushing or short circuiting to ground, it will generate an interrupt. This is what it's selling to us. Then we have to enable the interrupt. So EIMSK. If I go back to the registers before I carry on, EIMSK is over here, so we are using external interrupt. So we have to set the bit 0 of EIMSK in order to expect an external interrupt from the interrupt 0. So this is what is done over here, and that will be pointed and sent out as EIMSK is in the special function register. I can just use out instruction over there. So we enable the external interrupt 0, and afterwards we have to enable the global interrupt, which is in the I bit in the status register. So that's why we use, there's a special instruction which is called SEI, which enables the interrupts. Because if you don't enable this one, even if you enable this one, it's not going to receive any interrupts. So global interrupt enable has to be enabled. Okay, so address is pointing B, then the external interrupt is enabled, and also global interrupt is enabled. Then we carry on, we initialize 3, we initialize 4, and suddenly interrupt comes in. Okay, as you can see, as we are pulling up now, as the button is pressed, that means external interrupt event is occurred. It will short circuit to ground. Now, what will happen at this point on, as we are in LDI R31-4, and the next instruction is 00F over here, which is not appearing. Now, as we are going to serve the interrupt, we have to save the program counter address. So we get 0f for the low byte and 00 for the high byte. Now, as we have received an interrupt, while we are having an interrupt over here, the global interrupt enable is disabled. Okay, so that means we are serving an interrupt. I'm not accepting any other interrupt. Okay, and as the stack pointer moves further, as you can see, the pull-up is short circuit. Now what we need to look at is I have to go back where my interrupt service routine is defined at address location 2 in the interrupt vector table because of that. So my program counter is going to be jumping back to address 2. Okay, so as you can see, the program counter saves where we have just running the ordinary routine, and it goes back to interrupt service routine vector, which is hex 2. Hex 2 is telling us that we have to jump to the ISR, which is hex 12. So hex 2 is telling us that we have to jump to hex 12. The program counter points to hex 12, where we have got the external interrupt service routine. So when we reach that point, we start to serve the ISR. So we receive a data, and then we do some toggling over there, and we send out the data to port C. So these are just running. Program counter is changing. Now no interrupts anymore, and we are done with the ISR. Now when we reach to red eye, that means this sreg I bit is going to be set again so that we can expect a new interrupt. So we are making this pin ready and available for next press. So as we finished everything with red eye also tells the program counter, okay, go and fetch the addresses stored in the stack because we have to carry on the ordinary routine. So it will just go back and start queries on with the program where there is left and add those two numbers together. So adding 3 and 4 is just the ordinary routine in this case. So this is what we can do with this executing an interrupt. Let's see the first example and let's analyze how we can use these interrupts now. Use timer 0 to toggle pin port B5 in 4 microseconds while at the same time data is being transferred from port C to port D. Okay, so ordinary program is going to do is, it's just going to transfer data from port C to port D, and whenever the timer 0 counts 4 microseconds, it will generate an interrupt and it will stop the port C to port D transfer, and it will serve the interrupt service routine. So let's analyze it. We need to use timer interrupt. We have to use timer interrupt timer 0. Okay, and we can use timer 0, and we have to be careful over here. How are we going to configure the TCCR 0 as we are using timer 0? Let's use the normal mode. It says timer overflow interrupt. So we have to use T0 interrupt enable. We have to enable that one. And also no prescaling, normal mode. So these are all 0, 0, 0. This will be 0, 0, 1. Okay, that's the only difference over there. So we can say that TIMSK is going to be 0 hex 0, 1, and TCCR 0, it's going to be 0 hex 0, 1 as well. So these are what is going to be set for the control register and the timer interrupt enable bits. So we have to determine what happens after the reset. So that means after the reset, we have to jump to main. That's one thing that we need to do. And we have to place the ISR service routine for the timer 0 overflow. And if you need, we can look at it where it is. Timer 0 overflow. It's over here, which is an address x20. So timer 0 overflow is at 0 hex 20. Okay, so there we should place the ISR at that point. And then we have to initialize the main, which will be after the interrupt vector table. We have to initialize the stack because we have to save the contents whenever we receive an interrupt. Okay, so you can see how this is going to be done. Switch is going to be closed, then the LED will turn on. Okay, so this is what we are going to do over there. Initialize the stack and configure pins for that. Port C is going to be an input port. Port D is going to be an output port, as ordinary things that we have done previously. Then we have to set up timer for overflow and interrupt. So TIMSK will be 1 and TCCR will be 1 as well. So we have to enable the interrupts and the global interrupts, and then we have to enable the timer so that we can count 4 microseconds. You can do those calculations and you can easily get those out. Let's do it if you want. So we have got 8 megahertz. That 8 megahertz is going to give us 0.125 microseconds. Okay, and we are looking for 4 microseconds. So 4 times 10 to the power 6 divided by 0.125 times 10 to the power minus 6, which will give us 32. So 32 is the value that we need to load into TCNT. Actually, this is going to be 256 minus 32, 224. So either you use TCNT0 as 224 or you can use it as minus 32. They are both acceptable. Okay, so either one of those can be used. So we have to initialize a timer with these values and the TCCR, and then ordinary routine. So check the pin C and then send the value to port D. That's all we need to do. And while we are in the ISR, we have to think what to do. We can just toggle port B because it's already given over there. And when we reach to 4 microseconds in ISR, we have to toggle port B. Okay, let's see how are we going to do that. Now we start with .include. M128 def.inc. So we have to determine the reset, so .org zero hex 0. That's location for reset. And then we have to jump to main. And interrupt service routine.org, we said it's going to be hex 20, 0 hex 20, because of the ISR over here for timer 0 overflow. It's hex 20, so we have to use that. And we can say it's location for timer 0 overflow. So where do we need to jump? We have to jump to ISR routine, timer 0 ISR. Let's say OVF for overflow, because there's an out compare as well. And that's it. So we have defined where we are going to jump for main and for the ISR. Then the main program. So .org, we have to initialize main after address the interrupt vector table. So I'll just put it into 100. You can put it 50 as well. That's also possible. We start with the main. So LDI, let's initialize the stack. So I'll go back over here. We have to initialize the stack first. LDI R20 high, Ramend, out, SPH R20. And then LDI R20 low Ramend, out, SPL R20. Let's organize it this way. So we initialize the stack, and next thing to do is we have to define the ports. So let's just write a comment, initialize stack. Now the ports, so the port B, bit 5 is going to be an output, so SPI DDRB bit 5. So it is going to be an output. Then LDI R20, it's going to be 0. So DDRC is going to be an input, so that's why DDR out DDRC R20. And that's going to be an input. Then LDI R20 0 hex FF out DDRD, it's going to be R20, and that also going to be an output. So we defined the ports. Now we are ready to initialize the interrupt for the timer. So I can just say LDI R20, which we can write enable timer 0 interrupt enable. Timer overflow interrupt enable 0, which is this one over here. And that has to be sent to out TIMSK, and that will be R20. So enable timer 0 overflow interrupt. Then, as we have enabled the timer 0, we have also need to enable the global interrupt enable. Otherwise, we cannot expect an interrupt. Now, interrupt is done. Next, we have to initialize the timer. So LDI R20, we can set this to -32 as we already set, or 224. That's value for 4 microseconds. It can be 224 as well. And then that will be sent to the counter out TCNT0, which is going to be R20. Then TCCR value LDI R20, which is going to be 0x01. We just need to have normal mode, no prescaling. And that will be sent to TCCR0 R20. So the timer is also initialized. And then all you need to do is read pin C into R20. Then send the value port D R20. So if the switch is on, then LEDs will be on. If the switch is off, LEDs will be on. And we just need to do this continuously. So here means somewhere here. Oops. We have to loop this forever until we get an interrupt and do something else. So the main is done. In the main, initialize stack, initialize ports. As you can see, we are just doing block by block. Initializing the interrupt for the timer 0 overflow, initialize the timer so it starts counting, and do some ordinary stuff like read the pin C and send it to LED. Now we are ready to write an ISR routine. So ISR needs to have the same name as the whatever you call it over here. So I'm just going to copy that. Timer 0 overflow ISR. And what are we doing in that ISR? We have to read port B. Okay, so in R16 pin B, and then LDI R17, let's define bit 5, 0x20, then XOR R16 and R17, and then send it out to port B. Now, once we are done with the operation, we have to use red eye so that it returns back to the where it is left, and it will carry on doing what it is supposed to do. Okay, so that's the timer 0 overflow interrupt. Okay, so that's what we are going to get. And you can see the similar output over here as well. One more example. Use timer 0 and CTC mode to toggle pin port B5 every 40 microseconds, while at the same time data is being transferred from port C to port D. Now the difference over here is we have got 1 megahertz clock, and we need to do it in CTC mode. We have to toggle port B bit 5 again every 40 microseconds. Okay, so this is actually like, so if we draw the timing, this is where we have got 0 hex FF, and we have got OCR. Now 40 microseconds, when we start from 0, so from 0 up to OCR, then down, up to OCR, then down, up to OCR, then down, up to OCR, and then down. So this is where we have got the OCF zeros. Okay, so whenever it is reaching there, it has to stop and restart. Now, as it is a 40 microsecond, now we have to do that 40 microsecond to 0 to 39. This will give us 40 microseconds with 1 megahertz clock. Okay, so that's going to be 0 to 39. That means OCR 0, it's going to be 39. And TCCR 0, so we need to have TCCR 0 that in CTC mode, that means VGMs are going to change, which we are expecting 0 hex 09 as a configuration rather than 1, because 1 is giving us the normal mode, 9 is giving us the CTC mode, if you do remember from the previous chapter. Then we have to define the ports. So port B bit 5 has to be an output port, port C is an input port, and port D is an output port. Then apart from that, we have to read pin C and send it to port D. And in the ISR, we just need to repeat the same thing that we have done it before. So we can see it from here. And as we are doing CTC mode, we have to know the ISR vector. So if we go back to the vector table, so the timer 0 compare, which is CTC, is 1E. That means that vector is going to be 1E, where we have to place the interrupt service routine. So 0 hex 1E needs to be for ISR, which is timer 0 CTC ISR. Let's call it. Okay, so that's what we need to write over here. Then we have to initialize the timer with these values. OCR is 39 and TCCR is 09. Then we have to enable the interrupt. So the interrupt that we need to enable is the output compare interrupt enable 0. So output compare interrupt enable 0 has to be 1. So that means this is going to be TIMSK, which will be equal to 0 hex 10. It's going to be 2 actually. 0 hex 02 that we need to set for TIMSK. And of course, global interrupt enable has to be 1 as well. Then rest are similar to what we have done so far here, enabling the port C to be an input and port D to be an output, and transferring the data from one to another, which is already defined over here. And the ISR routine, whenever it reaches to the ISR, again, it will just toggle the port B and it will send out on and off values like this. So 1E has to be placed for the ISR, then 39 for OCR0, X9 for the TCCR0 CTC mode, and then enable TIMSK X2, or you can just do it like this, both acceptable. Global interrupt enable is set, and then ports are defined. Then do a typical routine, read the pin C, send it to port D. Whenever the interrupt comes in, whenever the 40 microsecond is done, toggle port B. So that's how we can use interrupts with the timers and interrupts with the timer overflow or CTC mode or external interrupt that we have seen step by step.